Thank you for organizing this. Everyone who has put any hard time and effort. This is really great, and I appreciate all of the effort that everyone has gone through to be here and to set this up. Really great. I never had the opportunity to go to one of the real Newton conferences back in the day because I was too young. But I'm here to share with you some of what I have reverse engineered regarding the internal serial slot on the MessagePad 2000 and 2100. Just to give you a little bit of background of kind of my journey through the Newton. In 1997, or maybe late 96, I don't remember the exact date, but there was a PC World Conference at the Jacob Javits Convention Center in New York City. And I attended that with a friend of mine, and Apple had a booth there, and they were presenting the 2000 at the time, I believe. And both my friend and I were blown away, and we both went home and bought them. And that was, at the time, a lot of money for someone who just had graduated high school. Along the way, I met Will Nelson, who ran a website called the Newton Underground, and kind of partnered with him, kind of ran the developer section, and kind of lost track with Will a long time ago. I don't know if he's still around, but it was a great time to be, and I still remember that website switching over to try to be a pen-based PDA Dash. I think it became. They tried to pivot after the Newton was canceled, but I don't think it really ever went anywhere after that. After college, I, one of the things I never really figured out how to do was develop. I forgot. There's a backdrop app that I built, and also a game called Columns, which Rob Bruce of Tactile actually distributed. So if you download that game Columns, it's kind of like a Tetris clone kind of thing, not really Tetris, but similar like falling tiles kind of game, and that was distributed through Tactile. I don't think I ever made $1 on that. I don't think anyone ever bought it. Newton IM was a Jabber client that I wrote at the end of college. I never really had I never was a Mac user back then. I was on the Windows version of the toolkit, and in college, I was able to finally start getting an emulated development environment, and really it made developing network-based software much easier. And so I tried my hand at a Jabber client, and it worked. And I think Paul even made some modifications and improvements to it since then, but I don't know the status of that. In 2005, I decided to try a Bluetooth internal board. I'll show you that. It kind of worked, and never really went anywhere. And then in 2015, I was able to finally successfully get a Wi-Fi module working with this internal port. And then in 2017, I experimented with accelerating, overclocking the Newton. And you see kind of my interest in the Newton goes cyclically. So my hope here today is share everything I've learned about this slot, maybe encourage other people to play with it. Because there's a lot that can be done with it. Because if you wait for me, it'll be 2027 before I get around to making the next thing, especially now that I have children. So just a bit of disclaimer here. Some of this work is 20 years old and still might have bugs from 20 years ago. And it's also hardware. So, you could set your device on fire, I guess, if you tried hard enough. So just, proceed carefully. So what is the internal serial slot? It's a little port that you can see by the green arrow there on the back of the main logic board of the 2000 and 2100. And it has a bunch of different functions. It has 3 serial channels, so 3 serial ports. It has access to unfused power, which is a direct line to the battery or power adapter. And you can actually put power into those pins if you do it properly and charge or power the device from the slot, which is interesting. There are multiple voltage rails. And by the way, I apologize. This is going to be very technical because, like I said, this is kind of like, if I get hit by a bus, I want to make sure that everyone knows how this works. So it's going to be very technical some places. I apologize. Just tune me out if I'm boring you. So there are 3 voltage rails in the Newton, 3, 5, and 12. The Newton mainly runs off the 3.3 volt rail. And it can enable and disable, I believe, the 5 and 12 volt power rails as needed. So for example, the backlight runs off of the 12-volt rail. And if you turn on the backlight, then the 12-volt power supply comes on. And if you turn it off, the 12-volt power supply goes off to save power. There's an additional GPIO pin, which can be used as an input or an output, just a signal. You can either signal, a binary on or off, and it can be an input or it can be an output. And there's also a sound input. And you'll see kind of the subtitle. This port was likely intended for a never produced modem. In fact, in some of the documents, it's actually referred to as the modem port. So, that's, I think what that sound input was for, 1990s era modem sound effects to be played through the speaker. But I don't really know how that's addressed in software. So on UNNA or your friendly mirror, you'll find the N2 platform docs. And I think Matthias and Paul alluded to these yesterday. They really outline, I think, how you would, if you were a licensee, kind of integrate with the hardware and software of Newton OS. And they're extremely valuable. I mean, I'm so glad whoever got them and published them. And the funny part is at the top, there's this stamp that's over on the right I recreated. It basically says Apple need to know confidential. So these were not intended for public dissemination, but thankfully they made it out because they really tell us a lot about not only the internal serial slot, but about some of the current, ROM extensions and Rex formats and things like that. So really important. Really quickly, if you're going to build something for this port, you'll need the connectors. So first of all, the PCB. If you're building a PCB, you want it to be thin, 0.6 millimeters or thinner. If you're using my designs as a basis for your PCB, my holes are just good enough. I mean, I measured with calipers and trial and error, but I don't have actual measurements for the device. So I did my best. You need 3/8 inch long 172 screws. And you really do need to countersink the screws and get them down as flush as possible to the board because it will put pressure on the back of the case and crack things and cause problems. So it really needs to be flush. The connector is an 8.8 millimeter pitch double row 32 position connector. Unfortunately, the correct part is now marked as obsolete. You can still buy them, I think, in quantities of 1,000 plus, and I think they're $1.50 each. So if you want to spend, $2,000, you can buy 1,000 of them. But every once in a while, they come in stock. If someone else is using them for something and DigiKey or Mouser decides to buy a spool, they may come into stock, but that's becoming less and less likely. There is an alternate connector that I've used. It's the Samtech part number there, but I think it's thicker board spacing. So even though it fits, it may create some fitment issues. So if you go as thin as possible on the PCB, you might be able to make that work if you really wanted to. So just a little bit more about the power in the Newton. Again, there's 3 voltage power supplies. They have limited power. So, you really got to make sure that you're not drawing too much. If you're going to use the power adapter input, which is an interesting thing that I haven't really played too much with, but I'll show a little bit today. There might be an error in the docs where it says that you need a 100 k ohm resistor connecting 2 different pins, but if you do that, nothing happens. And so if you do some math, and I think maybe they meant 1K, but maybe they didn't. And so if you're going to do this, I would take a sacrificial Newton and try powering it this way for a good long time with a battery and without a battery, and just make sure that it doesn't destroy anything because there may be an error in the documentation here. But as a general rule, if you're going to draw a lot of power, you probably need your own voltage regulator. That's what I did for the Wi-Fi card I'll show you. I also put a polyfuse in between, which is kind of the same thing that's on the battery pack in the battery pack, just so that if you start drawing too much power accidentally, you don't cause anything to release the magic smoke. And about this resistor for the power adapter input, if you're going to try to power from the internal serial slot, you can't just put this resistor and leave it there. because then the Newton always thinks that there's a power adapter connected. So you've got to kind of do some clever circuitry to connect up that circuit when you're powering the device from your internal serial slot, and disconnect it when you're not. That way, everything else works the same way. Any questions so far? I know this is probably more than anyone ever wanted to know about the internal serial slot. All right, well, we'll just keep going then. Probably put everyone to sleep here. So there are 4 serial channels in the Newton. Probably more if you count PCMCIA and other things. But channel 0 is the main serial port that you would normally use for docking, and it's available on both the external and the interior port. Channel 1 is the IR. I've never played with that. It's not on any of the ports because it's hooked to the IR. Channel 2 is the keyboard, as it's mentioned in the docs. But what's interesting is it's not the same keyboard as is used for the external keyboard, because channel 2 is not available on the external dock connector. And the other thing, if you look in the upper right, these are the various serial port locations. And the last one, I believe, is port 2. I don't recall testing it, but that's what my brain is telling me. And so it's actually identified as TBLT. So I assume that means tablet. Don't know what that was intended for, but it's not the same signals as used for the external keyboard. There is that little weird slot near the hinge that I always wondered if there was a ribbon cable supposed to come out of there and go to some other accessory. Maybe that's what that was for. I don't know. Channel 3 is called the modem port, and that is what I use for my accessories. But it's not available in Newton script or to Newton script applications unless you kind of explicitly tell the operating system that it's there. And that little snippet of Newton script there will do that. It'll add the location to the modem locations array. And then it'll be available to apps like PT100. So yeah, you need to do that. And some of you may have like third-party accessories that all do this. Like if you have like one of those USB boards from a certain company, which I won't mention, there's a little package that they have you install. Basically, all it does is this. So on the serial port connector, there are selection signals. Since both serial 1 and serial 3 are available in both 0 and 3 are both available. 1 and 3, 0, 3, but I don't know. I'm losing track. 0 and 3 are both available outside the outside connector and the inside connector. There's a signal that tells which one the Newton is intending to access. And if you're building an accessory for the internal slot, you really need to obey that signal. That way, you're not going to create contention. You're not going to try to drive the signals at the same time and have any kind of conflict, which theoretically could do hardware damage. But Matthias has found that evidence that maybe the internal driver is a little more robust and it won't really do any damage, which I think some third-party internal accessories rely on that, because I've looked at a couple of them that don't seem to obey this signal. They've just connected right up to the pins. But you really should only drive the port from your internal card when that signal is appropriately flagged to use it. So over on the right, I just gave you some information of how you would address this in software. The signals are on the GPIO 6 and DIO 22. GPIO, I believe, means that it's on the StrongArm 110 or 1100 directly. And I think the DIO, the digital IO, was like an extension that was part of the Voyager chipset. So it's basically, again, these are just signals that can make a pin go to 3.3 volts or go back down to 0. But this is how in software you would address those pins and change the signals. So originally what I was doing on the left here is I was manually toggling those signals when I needed to access the port. The problem with this is that the Newton OS also tries to toggle those signals. So if I say turn on the internal port for channel 0 and then go to PT100, which is a serial terminal app, and open the port, well, then Newton OS flips that bit right back down, back off, because it thinks I want to access the external port. So that was a problem. So what you have to do is you have to connect, and then you'd have to go to this little app and flip the switch after you were connected, and then things would work. But the problem here is that, it wasn't really very good. So I spent a lot of time reverse engineering the ROM to figure out how this was supposed to work. And I found the power registry, which tells the Newton which power supplies are needed for a given device, and allows you to register a device as needing a power supply or the internal slot. And upon opening the serial connection, then if like you open the modem port, it will automatically configure the pin as necessary to address the internal slot when you set this thing up. Sorry, went the wrong way. So you unfortunately can't control any of this from Newton Script. We can see these useful functions sitting in ROM, but they're undocumented. And so what do you have to do? You got to get out a disassembler. You got to start poking through the ROM, and you got to start tracing the functions, and you got to see, where these things are used. And once you find kind of something in ROM that you want to try calling, Eckhart has really shown the way to call these functions pretty easily. So once you've identified what you want to call, you make a stub or prototype class or function in your C++ header, and then you have to write a small assembly file with a simple jump table, that's supposed to say, for the implementation. So here's where it gets really nerdy, but you can see on the left, that's your class definition, and then on the right is your jump table, and then you can call this thing just like you would call any other library from C++. The ARM, mangled function name is there. You can, if you're looking through the ROM jump table and you want to know what a function is, you can actually run it through C++ filt and decode the mangled name to get the parameters and types out, which is kind of useful if you're reverse engineering. And then once you have all this, you wrap it in a function, you export it to Newton Toolkit, and you can call it from Newton Script, no problem. So these two functions, get subsystem power and set subsystem power, allow you to modify this power registry. So if I wanted to say, tell the Newton that I have a device on the internal port for subsystem 3, which would be serial 3, I would call set subsystem power, and I'd set the power flags appropriately. Like if I needed the 5-volt supply, if I needed the external port select, I would, it's a bit field there. You just OR them together and send it out there, and you're ready to go. Luckily, you don't have to do any of this because you can just pull my source code out of GitHub, and you're ready to go. You have a module, you can pull it right into NTK, and you can call these functions directly for your project. So we'll do a couple quick demos. I'll pause here. I went through a lot, but again, this is kind of, like I said, I'm limiting the bus factor. Now there's a whole bunch of people who know how to do this. And if I disappear from COVID-19, because, that's what we're all worried about nowadays. You guys all know how to do this. So any questions? All right. So I'm going to show a couple things today. I'm going to show the Newton Wi-Fi card. As Powell mentioned, there's 2, maybe 3 working in the world. I found one here that I think actually does work, but I'll show it to you in a second. I never was able to really send these around at the time because of some weird USA encryption export law that prevented me from distributing these, even though the encryption that was on board was publicly known and could be downloaded and done. But like for some reason, the US, I would have had to register for an encryption export approval, and I wasn't about to do that. I chose this module because it has a PPP server on board. So, and it's an AT command set. So it's basically a modem that connects to the Wi-Fi as far as the Newton is concerned. So the Newton thinks it's dialing up to a late 1990s ISP. And I'll show you that working. The other thing I'm going to show is an accelerator. In 1998, there was a company, PIC Solutions, who sold a product called the Implant. It was basically 2 separate crystal oscillators one with the current standard clock rate and one with an accelerated clock rate, and some really messy wiring to watch the power switch to toggle it on and off, because you couldn't just leave it on because it would make the sound higher pitched, because it would be clocking the sound card at a higher rate. And it would also prevent serial IO, because the serial chip was also clocked from that crystal. So you had to be able to turn it off. And this is the way they did it. My idea was, well, we've got this extra GPIO pin and I know how to toggle it in software. So I can essentially enable and disable the accelerator using that pin. And I use a little Tiny 8 Arduino microcontroller to watch the GPIO pin and reconfigure a solid state clock generator, which is nice too, because when you switch the clock speeds, it does it smoothly. There's no weird glitches or anything like that. And so I'll show you this working as well, but I never released this because I never really knew if it was, prime time or not. And I'll do a couple other proof of concept demos really quickly, just to show you that all this does work if you want to take the time to build something that interfaces here. So let me just switch my camera while I get things moved over here. Any questions? There's my mouse.
Paul has a question.
Yeah, go ahead.
Yes. Jake, maybe I'm gonna, because I have a few questions, so at the end, but now I want to tell you, I think if it's working, please just release it. I wanted that module in my Newton. Really cool stuff. Really cool stuff.
It works, but I don't know if it works. Like,
I'm happy to sacrifice one of my Newton to make a test.
Okay.
So
you've got a second here as well. I would totally throw down with that.
Okay, so here's we'll think about it. Okay, so here's some hardware. This was my first one from whatever back in the timeline, 2005. It used like an AT chipset Bluetooth module, and I don't remember if it worked or not. But it didn't work with Blunt because it was one of these modules that used like an AT command set, and Blunt was actually accessing a raw Bluetooth protocol of some sort. I don't remember, but. So then I made this one, which uses a Bluetooth module. And this actually, I believe, did kind of work with Blunt, but I had to leave the back case off because I'm not an RF engineer. And the antenna wasn't very good. And so I tried to hack an antenna onto the side to see if it would be any better. And it really wasn't. But kind of worked, but didn't. And then kind of put those aside for a while. These two down here are the Wi-Fi ones, and I have one in a Newton over here, which I'll show you actually working, similar to what Powell has. But this one is one of my early test boards, and you'll see it's got a bodge wire because I have this like blind spot when it comes to flow control, and I had my bits backwards, and so I had to bodge in an inverter to flip that signal. And I don't know if that's my fault or if there's an error in the docs. It's probably my fault, but just make sure your flow control is right if you're doing this. Otherwise, it thinks it's not ready for receiving serial. This is Connect One had a newer module that was supposed to replace this one, and I built a board that does work. What I didn't know is they removed the PPP server from this version. And so, it has an AT command set. Yeah, I can send commands to it. I can connect to the Wi-Fi. I can even use the AT command set is pretty advanced. Like I can, get the HTML from a web server, with encryption, HTTPS and everything. But without the PPP, Newton Internet Enabler wouldn't work. And so, I kind of, just shelved that one and then shortly thereafter, the company decided they didn't want to build modules anymore. And so you can't get these anymore at all, unfortunately. And then these are the accelerator boards. I don't know why I made so many of them. I'll test them and see if they work. These may have been failed attempts, but I have one that does work that I can show you as well, working. So that's the hardware. And I'd encourage people really, it's fun. It's a fun project. If you're doing Arduino, if you're doing, anything like even Raspberry Pi with 3.3 volt logic, this is accessible to you. The surface mount stuff, I took a little bit of learning on my part and some hardware. I can see my PCB oven in the back there. But it's fun to play with. So here is I believe this is my actual first Newton. It's very worse for wear. It's got a cracked case. The pen doesn't work. I was going to ask Frank to refurbish it for me once upon a time. I never got around to it, but I do have a sentimental value that I would love to see it restored to glory someday, but we'll see. In here is the Wi-Fi card, the same one that Powell showed yesterday. And so I'm going to just show you how it works. I'm going to run Newtscape here, and we're going to go to the, let's see here. What am I doing wrong? Okay, there we go. I'm going to delete this out, and we're going to go HTTP.
Mark, Jake, I'm sorry, I'm disturbing. Is it any way you could put additional light maybe on the screen, because we see very dark?
I tried to pop it. Let me go closer.
If it's possible.
The problem is my
light. Okay, right. Okay.
I did my best. Let me turn on the backlight. Maybe not.
Now it's much better. Now it's much better.
Oh, there goes my camera. Yeah. Give me just a second here. Let me get you back up and running here. Okay. Is that any better? I have it tilted up because
yeah.
I don't want the light to, okay.
Yeah, no problem. Much better now. Yeah, like that. Hold like that.
Okay.
Yeah.
So if we go to wwnc.online and hit go, what you will see happen is the cache version come up. How do I clear the cache? Remove from cache. Let's try this. Okay, so it's going to use Newton Internet Enable here, and you'll see when it connects, what it's going to do is it's going to run a couple of AT commands, and it's going to start a PPP server, and you'll see the PPP string there really quickly. If you're quick, you can see the old what the start of a PPP transaction looks like. And then as far as Newton Internet Enabler is concerned, it's connected to an ISP, and there's your web page, the Newton Conference web page there. Works with most apps, except most apps don't really work nowadays because of encryption and other things. But if you've got a serial card, and just to prove there's no cards in here, nothing up my sleeve. It's 100% from the. Sometimes the back comes off easy, and sometimes it does not. There's the card installed and working. Serial number 1. I think you have serial number 2, Powell. So Powell built his own.
That's correct. That's correct.
He built his own and sent it to me when it didn't work, and then I was able to send him back one working, and that was my way of getting around encryption law, because he had sent me his. I'm just repairing essentially. So that's that. That's the Wi-Fi board. There's a lot that could be done with that. If people were inclined. This is my Butterfly Newton. It's a MessagePad 2000 that I split apart and mounted on a piece of plywood so that I could poke at both the screen and the innards at the same time, if you will. And so what I've got here in the serial slot is a breakout board that just gives you the signals. Let's see if I can scoot it over here a little bit better. Try to arrange this a little bit better. Sorry. Nope, that's not better. That's worse. So just to kind of show you, there's the slot. There's the slot with the breakout board, and it's basically just giving you the pins. What I'm going to show you now is the fact that the 100K resistor doesn't do anything as far as Newton OS is concerned. If you come over here in the corner, I'm going to try to zoom in here. You can see, can you guys see that? It says battery. Well, I have the 100K resistor hooked up right now. And as far as the Newton is concerned, there's no power adapter connected. But if I hook up a 1K resistor, like I suggest might be the correct, you'll see it switches to adapter. I don't know if you can read that. So, if you're interested in playing with this, the specs in the document might be wrong, and you're going to just need to play with it. But my biggest concern is if I, for example, take this is, I don't know if you can see this. Let me move it over. This is my my little power adapter that if I plug in a standard Newton power supply to, I can prove that it's powering the Newton because I can eject the bat. Pay no attention to the man behind the curtain. It should have been it should have been continued to be powered. I don't know what I did wrong. But anyhow, maybe one of my connections is loose. This is all slapdash. But if oh, I know what's wrong. The power adapter's not plugged in. So anyhow, long story short is that you can power the Newton through that connector if you want to. I think that would be a really cool, and I'll talk about this later. Like if someone wanted to build a USB-C version of the internal serial board with power delivery, it'd be really cool to power the Newton through that port and be able to charge the battery. Unfortunately, I have small children and don't have the time to work on anything like that. So the other thing I will show in here, I'm going to just take out some of this stuff from the slot here. The first thing I'll show is the app that you may have seen the screenshot of in my deck. I'm sorry that this is so bad, but this lets you kind of control the signals on this port. So if you wanted to, for example, and I'm going to put my, you're not going to be able to see this, I don't think. Is there a way to turn on the light? No. Oh, anyway. DC volts. Can you see you kind of see, it's a little dim.
Yeah, it's quite dark. It's quite dark. Oh, now it's
okay. So
yeah.
I'm going to hook up ground to the ground pin. You can't see it on this side because it's not on the thing. And I'm going to hook up to the GPIO pin right here. And I'm just going to put it on DC volts. Right now it's DC volts. So if I toggle this to an output and I turn this on, you'll see that goes up to 3.3 volts. So that just shows that you can control these pins in software. And if you had a reason to, turn something on or off. Similarly, if I switch this back to input, you'll see it goes to 0, right? I'm going to disconnect the meter. We don't need that anymore. But if I put 3.3 volts on that same pin, you'll see that in software you can read this GPIO pin. Here we go, 3.3 volts. And that pin goes, I don't know if you can see it. So I'm going to connect it and disconnect it. See if I ground it, it goes to 0. If I put 3.3 volts on it, it will go to 3.3 to on and off. So you can, this is an input. You can, like if you want to add an extra hardware button to your Newton for some reason, you can do that. So yeah, I mean, this is all working. All the source code's available. If you want to play with this, you're welcome to. The other thing I'll show is in the prefs pane here. Where's prefs? Actually, I don't have it on this one. On this one. In the preferences, can't remember where any of my stuff is. Maybe it's in the setup. Oop. Setup. Prefs. This is where the internal serial slot. Oop, wrong button. Internal serial slot app that I showed you before is, and it works. It just basically tells the Newton that there's something in the inside, and it addresses that when you open the serial port. Oh, and this is also my my backdrop app, which if you see, it has the tabs. So if you wanted to go straight to the developer folder, you just tap the developer tab, and it goes there. So source code for that is online, but it's a Windows Newton Toolkit app. So it's kind of hard because everyone's using the Basilisk nowadays. Okay, so the last thing I'll show is the accelerator board. If you look carefully over here, you'll see this really weird circuit that I put. It's a little switch, and this is the original crystal. And again, it's hard to see. I apologize, but I desoldered the original crystal off the main board and put two little jumper wires. So as far as the Newton is concerned right now, it's running off its original crystal. It's just not on the board anymore. And so here's the piece of software that I use. Where'd it go? Uh-oh. This one? This one. So here's my software, and you can see that if you run the speed test here, I don't know if you can see that, but it's running at 161.9 megahertz, which is the standard clock rate. This is the accelerator board. I'm just going to turn it off real quick. Come on out. Just a minute. I'm going to put the accelerator board into the internal serial slot. And turn it back on. I'm going to flip the switch here. So this switch it's now going to run off of this clock source rather than the original crystal. And if I turn it back on and run the speed test, well, you'll get the same clock rate because the switch is on normal. If you flip the switch to high, that GPIO signal that I just showed earlier going to 3.3 volts now tells the clock that I want the faster clock rate. And if I do the test, you should see 222 megahertz. So what's nice about this is like I'm going to intentionally reboot the device by pulling the battery. When it boots up, I don't know if you notice how quickly comparatively it boots, but compared to a normal Newton boot cycle, it's much quicker because it's running, at 222 megahertz. So the original implant pretty much is the same thing, except this uses solid state components, whereas the original implant 2000 was kind of just TTL logic crystal oscillator. So that's it. Any questions so far? I'm sure there's none. I'm sure it was all completely understandable.
Paul has a question.
Yeah, of course. How's it going?
Yeah, I will be a little selfish and I'm going to ask first. I have a few questions. Actually, did you burn your Newton during your experiments?
I have not. It's been surprisingly resilient. I've not destroyed one yet. In fact, when I'm done, I might actually try to put the crystal back on the board here. This is a MessagePad 2000 as my piece of plywood. What happened? Oh,
sorry.
No, you took it away. That's all right. Yeah, this is my MessagePad 2000 as the board, as the piece of plywood says. I don't know if it'll run. I don't know if it'll run the web server as well as a 2100, but it'd be cool to hang it on the wall and just have it run the web server. But yeah, now I haven't burned one. It's been pretty resilient. I have made a couple mistakes. And that power supply thing is a little sketchy because it does say in the docs, if you do that wrong, you can damage something. That's why I don't really leave the power adapter hooked up to the internal serial slot for very long because I'm afraid of damaging it. But I think it would work if someone wanted to play with it.
All right. Could you tell us how fast the Wi-Fi board is? I mean, the data speed or something. Did you measure it?
So I've never done a measurement because I don't think there's like speedtest.net for Newton. But the thing is, it's using a serial channel, just like an old modem. So you're not going to get faster than the serial rate. I think the interesting thing is the specs say you should be able to go to like 230 kilobit per second, but I've never gotten that to work. It never goes that fast. So Really, you're limited to modem speeds with this method, unfortunately.
I think it's enough. Anyway, for Newton. Okay, last question about that turbo module, implant module. This module, could you tell me if this module affect the communication on serial ports like IR or something like this?
Yes, it's the same as with the Implant 2000.
Right.
So if you need to do that, you need to turn it off. I just wanted to see. I guess I can reshare my thing here. Hold on.
Yes, please do this.
I was just looking here. So if you look at I was just looking at the internet setup here. This is the internet setup for the internal board. I'm doing 115.200. I know it's terrible. Sorry. 115.200. But if you were to kind of, it does have a 230.400 here. But when I do that, 230.400, it seems to connect at 115.200 anyway. So I don't know if that was an error in the documentation or if I'm doing something wrong, but I've never gotten it to work. If I set this to 230.400, it's still 115.200. Now, just in the last few slides of my presentation, which I'll go back to, I just wanted to talk about where people could go from here if they really wanted to. Let me just get my desktop again and hit this. So we're back. If you look in the docs, there is a 2 megabit speed for serial channel 0 using an external clock. And I put the timing diagram on the right. I don't really want to figure that out. But I wouldn't be surprised if something like a modern ESP32's serial peripheral could be configured in a way that would work with this. But in theory, you could get up to 2 megabits according to the docs. Don't know if it works. Never tried. But there is a K external clock constant in NTK, which you use as the baud rate for addressing a device that's using the external clock. Again, the 230.4 never really got it to work. It says in the docs it should, but it doesn't, as far as I can tell. Someone would theoretically need to test this power adapter input to determine if it's safe and works as it expected. Does it charge the battery? Does it, does it give you any problems? Does it burn anything out? Especially with the 1K resistor, which is going against what the documents say you should use. Even I still think it's an error, but also the sound input. I don't know what that's, like I said, I think that was for the modem to be able to play tones, during connection and other, like your old modems used to do. I don't know if that just works or if you need to address it in software somehow. So something else someone could look into if they really were interested, but just some ideas as well for someone with more free time. An ESP32, if you're not familiar with it, is a single board like a SIOC or however you want to say that, is kind of Ethernet and Bluetooth microcontroller. And so, we talked yesterday about synchronization. I think Bluetooth Low Energy would be a really good way to pair with an iOS device or Android device, because the way it works in iOS, at least, is you can have the Bluetooth. You have an app on your phone that communicates over Bluetooth, and it's a form of background application. So it could be just running and wait for the Newton to make a Bluetooth connection, request a piece of data, and send it back. So like if you wanted to synchronize contact information or something like that, you wouldn't have to run an app on your phone. The Newton could just connect similar to the way an Apple Watch connects via Bluetooth. I know Matthias has talked about, how maybe Wi-Fi can be done. I've been focusing on using PPP. I think there might be some ESP32 code for doing SLIP. I've never tried it, but Matthias has talked about raw packets, and he's gotten more into the the networking side of things with Einstein. Might be a way to do it with LWIP or something, I don't know, and do it directly. But someone would have to write the firmware for the ESP32 for that to work, and then maybe a driver package for the Newton. And again, figure out that 2 megabit mode. You can get a little bit faster network I/O. Matthias, talk about an SD card slot. In theory, you could put an SD card in there with every Newton package ever made. You could put like all of UNNA in one SD card. You know, the other idea is you could theoretically figure out a way to shoehorn a LiPo in there using those power pins and that power adapter signal. And then, of course, the overclock accelerator. Again, I don't know if it's safe to run at an overclocked rate for very long. I mean, I guess PIC Solutions may have figured it out back in the day, but yeah, it's another option. So here's some additional resources. The Newton internal Wi-Fi board is up with its PC board design. You can take that and modify it, and the source for the Newton package to control the GPIO signals. All that is up on GitHub. There's some blog posts from when I was working on this and trying to figure things out, and then some older stuff like the backdrop, and I think there's some code up there that I used to use to export Note to SVG. Other things like that are kind of up on that site. So yeah, I hope everyone is inspired to go and play with the internal serial slot. It's great fun. Nowadays you can send off to have PC boards made for less than $20. You can get 10 boards made. You just have to wait for the rowboat from China to come over. And now with COVID, it might take a little bit longer. But you can get boards made, incredibly cheaply, and some of the surface mount stuff is a little bit difficult to do, but it's definitely achievable for someone, if they're interested in playing. Any questions?
Actually, I have a couple here. It's Orlando. The upgrade board where you're increasing the clock speed, does that actually create wear and tear on the Newton internals, or does it just
that's one of the. That's the one reason I never did it. I never released it because I don't know.
Okay.
The PIC Solutions people sold the product back in the late 90s, so I assume they thought it was safe. I also kind of use their design, like the output from the clock generator goes through a 100 ohm resistor before going into the Newton, into the pad. It goes into the pad where the crystal used to be. I assume that's the safe way to do it. If you look at the docks to the strong arm, they say that you should limit it to 1 volt. I just don't know. I just did it and wanted to see how it works. I guess I could leave it running for a couple of days and see what happens to this poor Newton, but that's one reason I never really sent them around, because I don't know what the long-term implications are.
Hi, it's Ronnie here. I bought 3 of them and was running it for quite a long time with no problems at all. But 2 of mine were stolen, so whoever stole them is probably still enjoying it. It was very, very robust.
Yeah, there's also, I've seen, I don't know if the website's still out there, but I've seen someone who kind of took the same approach with my switch. Like that switch that I put on here was really just for switching from the original clock back to the accelerator board. I just did that for this demo, but I have seen people essentially do the same thing with 2 crystals, and jerry rig a switch onto the outside of the Newton somehow. I can't say that's a good idea. I mean, the other thing is, I don't know that these jumper wires to the crystal are very good. For all I know, this is like broadcasting random RF that's causing interference with, who knows what. So I'm not an RF engineer, like I said before. I don't know what the implications are of doing this. But like I said, PIC Solutions did sell them, and I have seen other people kind of do a more jerry-rigged version that uses, like I said, 2 crystals and basically a switch, and you manually switch between the 2 crystals.
Matthias, did you have a comment?
Yeah, this was awesome. Thank you so much, Jake. It was a lot of fun, and don't worry, it wasn't boring at all. And I love the work you put into the integration into the operating system. You must have done a lot of reverse engineering to get that going. Yeah, the ESP32 does have plenty of memory and a huge ROM, and it does have a module for PPP, so it should probably be a drop-in replacement if you want to try that.
Yeah,
there's
I started to design one, and I don't know if I don't know how far I got. I started to design one, but
all right.
like I said, it might be 2025 before I get around to that. But I do have a couple more of these breakout boards. You know, if anyone, but like you would have to get the connectors. You know, just go through my stash here.
Yeah, back then I had 350 of those connectors made. It was the minimum order. I needed 5, and I still have a few left over. So if anyone's interested.
Oh, that's good to know. I bought a now they're on the floor. But I bought a bunch too when they were available. You know, minimum orders kind of suck, but
Yeah.
you know, they're the right parts so that they fit right.
I also saw that there are Chinese modules out there for the USB-C ports that deliver right away 12 or 19 volt or something of power and do all the power management. So that would be really nice. And there's also a new version of the ESP32 that doesn't have the Bluetooth, unfortunately, but it has USB. So we could use a USB-C port for power and data. That would be one version. I mean, there's so many things out there to experiment with. It's just pretty crazy.
Yeah, there is. And the thing about the power delivery is, I think 9 volts is a valid USB power delivery option. So you would need to have a voltage regulator on board that regulates it down to 7.5 volts, just like the power adapter. And then, you know, it involves a little bit of trickery because, you know, and this is kind of where like I kind of bottomed out was, you know, you need to build that voltage regulator needs to be able to withstand, you know, accidental 20 volt inputs from USB power delivery, because you want to trust but verify. So, you know, and so you need a regulator that can regulate down from 20 volts all the way down to 7.5. You know, and it was a lot of I couldn't find the part that I wanted to do that. I'm sure it exists. I couldn't find like the combination. But yeah, I think that's going to become more common now, is like little modules that have USB power delivery built in, and we might be able to use something like that when it becomes a little bit more available.
But yeah, thank you very much. It's very cool.
Yeah, take the software and play with it. It's fun. I mean, you know, it really is. You know, a testament to, you know, where they thought they were going. They never made this modem, but they had all the infrastructure there, and the software already, you know, more or less had the support for it in software. It's just not in the Newton script side. It's only available from the C++ side.
I ask one more question.
Yeah, good.
Oh, great. The other question I had was the wireless card themselves. I mean, I know that we can use presently A or B cards on the PCMA side. This card that you're working on, would that be bringing it to like other connections like N or that sort of thing to Handshake, or is that?
Yeah, it does do WPA2, and I think it's N. Maybe BG, maybe VGN. I don't remember, but you know, unfortunately, like I said, this module just isn't available anymore. I don't know where they went. It's just not available anymore. The company decided to get out of the module business. They sent me like one final firmware update and then said, you know, sorry, we're not selling these anymore. I have this other module here that I really hoped that they would get around to adding PPP back to the firmware, but it doesn't seem like that's in the cards. So, you know, my approach was, you know, emulate the modem, but you know, we might be able to do something more sophisticated where it's actually emulating an Ethernet card, but it doesn't use you know, the AT command set it also has like with AT commands, you can connect to an SSH server, for example, or you know, retrieve a web page, the content of a web page, even with HTTPS, because the module knows how to do it. But the software on the Newton side is lacking. So, you know, there's a lot that can be done with this port. It's just we would need to build the hardware. Like I said, we don't need to reverse engineer the Newton OS anymore, really, other than maybe for integration points. But the serial port stuff is pretty much figured out.
Thank you.
So guys, that's the end of the time. Jake, that was a really amazing presentation. I think everybody agrees.
I wish I could provide everyone a board, but unfortunately,
that was my next question.
the module is just not available. So, you know, like I said, it goes in cycles. Maybe I'll get the inkling to start playing again, but I would really encourage, you know, people to. The other thing is you can start by experimenting externally. You know, just you know, if you get an ESP32 to, you know, connect via the external port, then we could then apply the miniaturization and the surface mount technology to make it go internal. So I know that people have done this a lot with Raspberry Pi, but the problem is Raspberry Pi, you really can't shrink down. Even a Pi Zero is too big to fit inside the case. So, you know, like I said, I know that Raspberry Pi has been mentioned a couple times here. If you're into Arduino or Raspberry Pi, this is all very accessible if you want to play with it.
Maybe we should raise the Kickstarter for you.
Yeah.
Yeah, the problem is you can't kickstart time. It's just, you know, I have a kindergartner and a 4-year-old and a 6-year-old, and we're homeschooling them as everyone is. And, you know, it's just very, very busy in this household, but, you know, we're making do. Everyone's happy and healthy, so we can't complain.
Good. I noticed that Doug and Frank are here. We're a little bit over time, but if you guys want to ask your questions, go ahead, Doug.
Thanks, Noah. Jake, how can I help with your homeschooling so you can do the hardware development? No, that's not my question. My question is, do you have a Google alert going on so that anytime somebody does do an order of 1,000 of those units, it pops up on your screen so you know to take a peek at it?
I haven't set up anything like that. I mean, I have, like I said, maybe they're probably all over the floor behind my bench now, but I have about 30 of them probably. And Matthias, it sounds like you've got a couple hundred. So,
No, I still have probably about 30, 40.
30, 40. Okay. So I misunderstood how many you ordered. Yeah. So, I mean, like I have enough to experiment with, but you know, it's, yeah, I think that these connectors, just like the external connector, I have 2 of the external connectors as well. I don't know where those are, but they're like rarer than gold. I think someone on the list was trying to sell them for like $20 a piece, and I was not about to pay that price. But I have them taped inside an old CD jewel case here.
Precious.
I don't know what I'm going to do with them, but they're hard to come by.
Yeah, I did order 350, and they also made it over the floor. That's why I have about 50 left.